Section 4.6 deals with optimization, which are word problems where we're actually looking to maximize or minimize something. So some guidelines to solving optimization problems. First, you're going to want to assign a letter or a variable to each thing that's mentioned in your problem, and you draw a picture if necessary. Then you find the expression for the quantity that's going to be optimized. Then you're going to use the conditions in each problem to find the quantity to be optimized as a function of one variable. And finally, we want to optimize the function over its domain. So let's look at example 1 here. It says to find the dimensions of a rectangle with an area of 108 square feet that has the minimum perimeter. So it wants us to first assign a letter to every variable. So if we are looking for the dimensions of a rectangle, we know that we're going to have length and we're going to have width. Then it's going to say we need to find an expression for the quantity that is to be optimized. It's asking us to find the minimum perimeter. So the equation for perimeter of a rectangle is P is equal to 2L plus 2W. Step 3, use the conditions in the problem to find the quantity to be optimized as a function of one variable. So what it's asking us to do is we need to rewrite this either all in L's or all in W's, and there has to be something within this problem that'll help me do that. So let's take a look at the problem again. Find the dimensions of a rectangle with an area of 108 square feet that has the minimum perimeter. So I know that my area, A, is equal to 108 square feet. Well, I also know that the area of a rectangle is length times width. So in this case, length times width is going to equal 108. So what I can do is solve this for either length or width. I'm going to solve it for width. So dividing both sides by length, I get that my width is equal to 108 over L. And then I can take this and substitute it in place of my width in my perimeter equation to get a function in one variable. So then we know that P is going to equal 2L plus 2 times 108 over L. I want to keep going with this. What I'm going to need to do is distribute. So P here is going to equal 2L plus 2 times 108 is equal to 216 over L. And now if I want to find the minimum perimeter, what I need to do is do the optimization, which again, how do I find minimums or maximums? I take the derivative. I look for those critical numbers. So for this one, before I take the derivative, I should really make sure that I clean it up. Well, I know that perimeter can also be rewritten as 2L plus 216 L to the negative first power. Now if I take the derivative, I know that P prime is equal to, well, the derivative of 2L is 2, and here if I multiply I get negative 216 L raised to 1 less, which is the negative second. So then I know that I have P prime is equal to 2 minus 216 over L squared. I need to figure out where this is equal to 0. So 2 minus 216 over L squared is equal to 0. If I subtract 2 from both sides, and then cross multiply by putting my negative 2 over 1, negative 2 times L squared is negative 2L squared. And 1 times negative 216 is negative 216. Divide both sides by a negative 2, and I get L squared is equal to 108. To solve for L, I need to take the square root of both sides. So I end up with L is equal to plus or minus. Now the square root of 108, the largest perfect square that divides 108 is 36. It's 36 times 3, so this becomes 6 square roots of 3. Now we have two answers here. We have L is equal to 6 square roots of 3 and L is equal to negative 6 square roots of 3, but we know that length cannot be negative. So the dimensions for my length for this rectangle is going to be that my length should be 6 square roots of 3 feet. To find my width, I'm just going to plug in what I know for L back into how I solved for W. So I know that W is going to equal 108 over my length, which is 6 square root of 3. I know that, well, 6 goes into 108 18 times. So I have 18 over the square root of 3. If I rationalize this by multiplying top and bottom by the square root of 3, I get 18 square roots of 3 all over 3. Well, this reduces to 6 square roots of 3. So the dimensions for this rectangle are, my length is going to be 6 square roots of 3 feet by my width of 6 square roots of 3 feet. Let's look at example 2. Example 2 says a company manufactures and sells X digital cameras per week. The weekly price demand and cost equations are P equals 400 minus 0.4x. This is my price demand equation. And C of x is equal to 200 plus 160x, and that's my cost equation. Part A, what price should the company charge for the cameras? And how many cameras should be produced to maximize the revenue? And then what is the maximum revenue? So what price should the company charge for the cameras, and how many cameras would be needed to maximize the revenue? So what I need to do first, well, I don't need to assign variables here because the variables are there. X is equal to the digital cameras per week sales. So I already know that. And I know that P is my price demand equation and that C of x is my cost equation. So I don't need to assign variables. The second thing is to find the expression for what needs to be optimized. So here I know I want to maximize my revenue. Well, remember your revenue function is always x times P. So in this case, my revenue function is going to be x times my price demand equation, which is 400 minus 0.4x. If I distribute my x, I get that my revenue function is equal to 400x minus 0.4x squared. So again, I need to maximize my revenue. So I want to take the derivative here. So r prime of x is going to equal 400 minus 0.8x to the first power. Then I need to figure out where this is equal to 0. So 400 minus 0.8x is equal to 0. If I subtract 400 from both sides and then divide both sides by negative 0.8, we can do that on a calculator real quick. So 400 divided by negative 0.8, negative 400 divided by negative 0.8, and I get x is equal to 500. So x, recall, represents the digital cameras per week. So the company manufactures and sells X digital cameras per week. So X represents the amount of digital cameras. So here it says how many cameras should be produced. So 500 cameras need to be produced to maximize my revenue. And then it says what price should the company charge for these cameras. So the price is determined by our price demand equation. So P would equal 400 minus 0.4 times, instead of x, I'd write 500. Again, grab your calculator. So on our calculator, we would say 400 minus 0.4 times 500, and we'd end up with 200. So the price it should charge is $200. The number of cameras that maximize revenue is 500. So the last thing is, what is the maximum revenue? Well, if you are making 500 cameras, to find the max revenue, what you need to do is find R of 500. So on a calculator, we would say 500 times 400 minus 0.4 times 500. And we'd end up with 100,000. So the maximum revenue we would have is $100,000. Now part B says, what is the maximum weekly profit? So here we need to maximize our profit. And then how much should the company charge for the cameras, and how many cameras should be produced to maximize our profit? Well, recall our profit function is equal to revenue minus cost. So I know what my revenue function is. I'm given my cost function, so I can determine my profit function. So my profit function, P of x, is going to equal my revenue function, which is that 400x minus 0.4x squared. And I need to subtract off my cost function. We'll recall the cost function was given as 2,000 plus 160x. Now don't forget to stick it in parentheses so you remember to distribute that negative. So let's distribute the negative and then to combine like terms. So we get 400x minus 0.4x squared minus 2,000 minus 160x. Combining like terms, we get that my profit function is negative 0.4x squared plus 240x minus 2,000. So I need to maximize my profit, which means I need to take the derivative of my profit function. So P prime of x would equal negative 0.8x plus 240. Now I need to set this equal to 0 and solve for x. So negative 0.8x plus 240 is equal to 0. Subtracting 240 from both sides, I get negative 0.08x is equal to negative 240. Dividing both sides by negative 0.8, and I get that x is equal to 300 cameras. So 300 cameras would have to be sold in order for us to maximize our weekly profit. So how much should the company charge for the cameras? And how many cameras should be sold? So we need 300 cameras to be sold. So we have this last part. Then it's asking us to figure out how much we should charge for them. So we need to figure out my price. So my price would equal 400 minus 0.4 times 300. And again, you can grab a calculator for that. But my price, if we do that in a calculator, we'd end up with $280. So we should charge $280 to maximize our profit. And then it asked us, what is that maximum profit? Well, that maximum profit is going to be whatever P of 300 is. So if we plug 300 in place of the x in my profit function, and we can do that on a calculator, we'd end up with negative 0.4 times 300 squared plus 240 times 300 minus 2,000. And we'd end up with the maximum profit that we would make is $34,000. So our max profit is $34,000. So for part B, the maximum weekly profit is $34,000. The amount that the company needs to charge for the cameras is $280. And the amount of cameras that it needs to make to maximize the profit is 300 cameras. Let's go to number 3. Example 3 says, the management of the Unico department store has decided to enclose an 800 square foot area outside the building for displaying potted plants and flowers. One side will be formed by the external wall of the store. The two sides will be constructed of pine boards, and the fourth side will be made of steel fencing. If the pine board fencing costs $6 a running foot and the steel costs $3 a running foot, determine the dimensions of the enclosure that will be erected at a minimum cost. So we need to minimize our cost. Well, since what we're looking at is this area right here, we're going to say that W is equal to wood and that S is equal to steel. Now, if I'm going to minimize my cost, well, the cost of creating this is going to be, well, I have two sides made of wood, and I know that the wood or the pine board costs $6 a running foot. So 2 times $6 times wood, plus I know that my steel costs $3 a running foot, but I'm only going to have one side that's going to be steel. So $3 times S. So there's my cost function. So we could also write this as just 12W plus 3S. So now we need to go back and figure out what information it gave us, because it must have given us some information so we can transform this into an equation with one variable. So again, the management of the Unico department store has decided to enclose an 800 square foot area. Okay, well then that gives me my area. So I know again that my area, in this case, this would be rectangular, and since I'm using W and S, would be W times S. So 800 would equal W times S. So I'm either going to solve for W or S. In this case, I'm going to go ahead and solve for S. So if I divide both sides by W, 800 over W is equal to S. And then I would take this and substitute it in place of my S in my cost function. Therefore, I get that C is equal to 12W plus 3 times 800 over W. If I distribute and rewrite this, I get that C is equal to 12W plus 2400 W to the negative first power. So I'm minimizing my cost, so what I would need to do is take the derivative. Find the derivative of this cost function. So C prime would equal 12 minus 2400 W to the negative second power. So then I need to find where this is equal to 0. And we're going to just move that right over there. So I have 12 minus 2400 over W squared is equal to 0. If I add 2400 W squared to both sides, I get that 12 is equal to 2400 over W squared. If I put my 12 over 1 and cross multiply, I end up with 12W squared is equal to 2400. Divide both sides by 12, and I get that W squared is equal to 200. Taking the square root of both sides to solve this, I end up with W is equal to plus or minus. The largest perfect square that divides 200 is 100, so this would be 10 square roots of 2. Now, just like the last problem we did, we have two answers here, positive 10 square roots of 2 and negative 10 square roots of 2. Well, we can't have a negative dimensions, so we know that our wood would be 10 square roots of 2 feet. To find the dimensions for our steel, remember that my steel was equal to 800 over W, so this would be 800 over 10 square roots of 2. Well, this reduces to 80 over the square root of 2. If I rationalize the denominator by multiplying top and bottom by root 2, I end up with my steel would be 80 square roots of 2 over 2, which reduces to 40 square roots of 2 feet. So the dimensions would be for my pine wood to be 10 square roots of 2 feet and my steel to be 40 square roots of 2 feet. That's it for section 4.6.